Hey there, guys. Jeff Clark here, and I'm going to be looking at a couple sections today in beginning algebra, and it starts off leading you through a course that ends for us with looking at graphing lines, equations of lines, and we're going to go through a journey of topics that would include factoring and polynomials and operations of polynomials and radicals and a number of other topics too. But to begin, we're going to start looking at number classifications, vocabulary, and we'll be taking a look at a few properties as well in algebra. Let's get started. What I'll be using is some pre-designed pages that will have problems here. Of course, this being a recording, you'll be able to pause it and write down your own information on your own paper. Number classifications. Now, for some of you who have a textbook, Martin Gay, it's going to be in section 1.2. And everybody else who doesn't have that particular textbook and author, you should be able to find this in any beginning algebra class textbook. And most classifications will have a hierarchy, and real numbers usually is what we're going to be focused on. And everything's a real number. Just think of it that way, with one exception, which I'm just going to make a statement about it today. And that's it for beginning algebra this course. We won't look at these type of numbers, which are imaginary. Imaginary numbers sometimes are called complex. We won't look at, but it is another number classification that an advanced algebra class and beyond will take a look at and see how to handle those. For us, it's just all these kinds of numbers that we'll be seeing down here. So at the top of the food chain, so to speak, are real numbers. Everything is determined to be a real number. And from there, every number can be broken down to other categories or classifications, and that's what we're going to take a look at. So think of everything as a real number, everything you can think of. I've shown you fractions down here. These are all real numbers: fractions, decimals, plain old numbers like the number 100. Those are all real numbers. And then those unusual ones that you may have heard about, radicals. You might pronounce that root 3 or square root of 3. And of course, that's the famous pi. I think everybody has seen that. So there's a pile of numbers that cannot be put in or made into what we call a fraction. Now, all of these are fractions. This is called a simple fraction. That's a mixed number, a mixed fraction. That's a terminating decimal. Now, terminating decimal right here can be made into a fraction. That would be 35 over 100 because of place value. And as you can see, that's a fraction itself. So any number that can be made into a fraction, basically like this right here, that's a fraction because you can make that into a 1 in the denominator. Any number that can be made into a fraction is considered what's a rational number. Rational are fractions. Irrational is another classification that has numbers that can't be made into a fraction. So that would be these funny numbers: pi, anything like a square root of 101. But a square root of 100 over here, square root of 100, because it's 10, because that's 10, and 10 kind of feels like this, where you can put a 1 underneath it. that would be considered rational, where that's going to be considered irrational. Now, irrational is a pile of numbers that's set apart. As you can see, the rest of the hierarchy, as we go down, is under the column of rational numbers. So when you start with the rational numbers, which are all the numbers out there that doesn't look like that, then a selection of these would be called integers. And as you can see, I'm showing you some examples of what's called integers. There are no determining denominators, fractions, not a one. We don't count one. So for instance, that one there, I just stuck a one underneath. 100 is called an integer. The number 0 is called an integer. But this number right here, 0.3 forever. And by the way, I think all of you know that 0.3, or if you don't, is the famous 1/3. Repeating decimals basically are fractions as well. These two are integers. That one's not. None of these are integers. Integers are counting numbers, positive and negative, and includes the number 0. Then below that are whole numbers. Now, some of these are whole numbers. This is like some of these are integers. Some of these are whole numbers. And then some of these are what we call natural numbers. So the whole numbers, the smallest whole number is 0. And then it's all positive after that. So 0, 1, 2, 3, and forever. And then the counting numbers, sometimes we call them natural numbers, would eliminate the number 0 and starts with the number 1 and proceeds higher than that. So these are called number classifications. And if you ever encounter those, hopefully you'll be able to know, or even the language later on in a course like this, applications or word problems, they'll talk about particularly like integers. Integers comes up a lot. And so then you'll have an idea what an integer looks like. Be numbers that are like these. Okay, that's 1.2. That's what we call 1.2 section for those of you in the textbook that's published by Pearson, but it's the author's Martin Gay. Okay, the next section would be 1.8, or on algebraic properties. So in algebraic properties, we're going to have a number of them that you would say you just do it. You naturally do these. Growing up, we've learned how to add numbers. 5 plus 3. You'd say 5 plus 3, 8. But then someone says, what's 3 plus 5? And you say, well, that's the same thing. You're right. 3 plus 5, 5 plus 3. That indicates changing the order, basically indicates a certain property title. So that's what we're going to learn is properties are going to be commutative. Then the next one or another one would be associative, and then a couple other ones, identity, inverse, and then distributive property. So the first one I'm going to look at would be called the commutative property. And there's addition and then there's multiplication. Every one of these properties, every one of these with the exception of the distributive is a standalone property. But each one of these has one for addition and one for subtraction. Excuse me, addition and one for multiplication. Then you might ask, well, what about that subtraction or even division? It turns out that subtraction is defined in regards, addition defines subtraction. I can make any subtraction problem into an addition problem. I can take 3 subtract 1 and make that into an addition problem. That's 3 plus a negative 1. So subtraction is defined within addition, and likewise with division. It's defined within multiplication. So there's only additions and multiplication, but I need that listed. If you ever take, let's say you took an exam from me, I would indicate that you'd have to have specifics, whether it's multiplication or addition. So as I said, 3 plus 5, 5 plus 3 is 8, same thing. That's just a demonstration of the property that's called commutative property for addition. The one for multiplication, similarly, 2 times 7, 7 times 2, it doesn't matter. This is like a formal definition with variables. And as you heard me say, variables, algebra has a language, lots of vocabulary. Variable typically is a letter of our alphabet, but it could be any alphabet, like the Greeks. We attribute a lot of mathematics to the Greeks. So it could be this is like theta times, let's say, alpha, which is the same as alpha times theta. Yeah, those are just variables. The associative property, okay, is different in that there typically is at least three things, either variables or numbers going on. And it's all about the grouping symbols. And notice the letters right here, ABC, ABC, they haven't moved. The grouping symbols have moved. Over here, well, what's moved? The variables. There's no grouping symbols. It's just the variables. So this one here, for instance, I could have A, B, C is the same as C, B, A, which is the same as A, C, B, and so on. No grouping symbols. You just mixed the order of the products. Here, I'm moving parentheses, and if you remember, P, E, M, D, A, S. And for maybe 100 years, I don't know how long, when I was learning mathematics at the beginning stages, I was taught Pemdas, which is acronym. Let's see, some people remember, please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. There's other ways of remembering the letters, or we just say Pemdas. Parentheses is first. So I would do parentheses here or parentheses there first. Exponents or powers is next. Now there's no exponents or powers on this one. Multiply is next from left to right. These are all left to right. Multiply, divide, add, subtract is all left to right. So you do the multiplication next before division, and then division before addition, and lowly subtraction is at the end. You wait for subtraction till the bitter end. So when I have an example, for instance, I'll let maybe A be 3, B be 7, and then C be 5. And over here, I put the 3 down again, and then I have the 7, B with 7, and then this is 5. If on the left-hand side I do Pemdas here, that means I do the 3 plus 7, parentheses. I have 10 plus 5. I wonder if that's the same as 3 plus, and over here you do the 7 and 5, which would be 12. Is 10 plus 5, 15, the same as 3 plus 12? It is 15. It's just a demonstration of something you would naturally probably do. We call it the associative property for addition because there's adding in here. Similarly with the multiplication property, the associative property for multiplication, same numbers, let's say 3, 7, and 5. I typically will use a multiplication dot right here, typically. Rather than the multiplication x, because that looks like a variable. I typically put slashes through my 7s because if I get sloppy, sometimes I do, it starts looking like a 1. The 7 starts looking like a 1. So I typically put slashes through my 7s. And so this would be times 5. So inside the parentheses first, again, Pemdas, you leave the 3 alone times, what's this, 35? And that's 105. And the same thing here would be, what, 21 times 5? And that's 105. Check. Next property, we have the inverse property for addition. And it's just say if you take a number and you add its opposite, O, P, P, O, I said opposite. Opposite. The opposite sign of 3 is -3. If I take 3 and I add its opposite, you're always going to get 0. Every time you take a number and add its opposite, you'll get 0. And the multiplication property with the inverse, you use the word reciprocal. Reciprocal. So if I take a number, let's say it's 5, and I multiply it by its reciprocal, 1/5. Of course, when you multiply straight across, you're going to end up 5/5. Yep, that's 1. So you take a number and you multiply it by its reciprocal, it's going to be 1. Here's another example. Let's say instead of a whole number like 5, let's say I take a rational number like 2/3 and I multiply it by its reciprocal. Flip-flop. Yep, you're still going to get 6/6. You're still going to get 1. Back over here, the word opposite. We call these additive inverses, opposites and reciprocals. So I think those are two that speak for themselves. And finally, we end up with what's called the distributive property. The distributive identity property before distributive property. The identity property for addition just says this is called the identity number. Identity number 0 is the identity number for addition. That means if you add 0 to anything, you don't change it. 0 doesn't change it when you add. 1 doesn't change it if you multiply. So for multiplication, squeeze that number in. The identity number for multiplication. Okay, finally, the distributive property. And you probably have heard that often in your early algebra, well, early math, high school, middle school, maybe even elementary now. Distribute something, to distribute something. Even distributors in real life, I've heard there are distributors, they take products and distribute it to different, say, businesses. So I'm going to take the number 3 and distribute it, give it via multiplication in mathematics, by multiplication. So that's 3 times 4 and 3 times 5. And if you work these out separately, you get 12, 15, and then that's 27. However, if we ended up doing PEMDAS on this, you would have done inside the parentheses first, and that leads us to the 9, and you get the same 27 at the end. So the distributive property, all the properties actually lead to correct mathematics. You can't break the rules. Okay, with that in mind, that's 1.8 and 1.2 in your first, at least for our course, beginning algebra. Okay, so until the next section, which we're going to be looking at the next chapter on solving equations, small equations, got to come up with some vocabulary first, but we'll take a look at what we call chapter 2. So until the next video, see you later and take care.